This section is on linear regression, and what we're going to do here is we're going to take a look at gun homicide rates in the U.S. and then determine whether additional regulation or more stringent regulations on firearms can help the situation. At least will make a contribution there, hopefully. So here you see that in the U.S., as it says here, we stand out in gun homicides. We have about 3 to 4 times the level of homicides per capita or per 100,000 than most any other nation in the world. Okay, so that's what we're going to take a look at. So that's more or less the problem statement, and the more or less the standard that's always or a lot of times held up is this is Australia, and they had a massacre in Port Arthur in 1996. So and then they introduced very strict gun control legislation, and so the homicides by firearms has decreased from 500 to 175. Accordingly, in that time, in the U.S., we've seen the number of homicides cut in about half, maybe a little bit over half. Okay, and then that's all homicides from firearms. So knowing that, what we're going to do here is we're going to take a look at what I call the efficacy of gun control legislation. And here are some of the statistics based upon that previous chart. You'll see that the per capita homicide rate, or the mean homicides in 2013, these are by state numbers. The mean is about 180 or 178.9. The median for all the 51 states, and this includes the District of Columbia, the homicide rate is about 87, and that's about all we can talk about there. The sum is about right at 9 or 10,000. Okay, and the number of observations is 51, or that would be our sample size that we're going to be taking a look at here. So all that being said, the problem statement is pretty straightforward. We're just trying to determine. Well, first off, the problem is that obviously the U.S. has greater homicides. Let me make sure I spell that right. Homicides by firearm than most modern economies, if not all modern economies. And as we mentioned there, we're obviously as a citizenry or as a country, we're trying to find a way to reduce the homicides by firearms, and that's the purpose of this study, is to really do a quantitative analysis. We're going to do a quantitative analysis to determine if strengthening the existing gun control legislation in the United States will indeed lower the number of homicides by firearm. And the reason we're going to do that is because it's become a serious public safety issue and what have you, and also it's a safety issue for all of us here in the United States. And then there's the issue of additional legislation could impede on our Second Amendment rights to keep and bear arms. So depending upon which side of that argument you're on, there are many, many reasons or purposes as to why this research might be important. So the 2 variables we're going to take a look at is this is a blended score of strength of legislation, and don't be overly concerned where that came from. It's just mostly from there's a Brady Institute, and then there's a number of other national surveys, and the mean score is 8.6. And here again, you've got a count of 51. And so these are the strength of legislation as rated by these different entities as to how each state is doing. And then each state has a firearm homicide rate. And the mean, this mean is going to be a little bit lower than the overall national mean because it's not weighted quite the same as a national population or a national incidence rate would. But about 2.6 on average, about for each state, about 2.6 homicides, firearm homicides per capita per 100,000 population. Here's our sample size again, which was 51. And the year for this is 2013, and these are the FBI statistics from 2013. And as I said, these are a couple of different surveys that are done as far as what the strength of legislation is by state. Now what I've done here is I've created a scatter plot. And as you'll see on the x-axis, this is the strength of legislation. And on the y-axis, we have homicides per capita. And these represent the data points for each one of these states. So for example, this would be an individual state here. And so the blended strength of that legislation would be roughly about 37, and the homicides per capita would be roughly around 4. Okay, and then likewise, here's another data point. Let's get one that might be just a little bit easier. Here's one at 5. Okay, that is the blended strength of the legislation, which is 5, and then the homicide rate is about 2. Now you see a couple of things going on. One is you've got a number of outliers that are going on here. So those that might be important. Some, as you know, would potentially take the outliers and disregard them. Others would find a way to mitigate those. But we're going to just do a straight up analysis here, and we're going to keep the outliers in the analysis. And you can see also that here's a line that this is the best fitting line for all of those combinations of states and their associated homicide rate combined with the strength of the legislation in that individual state. So our causal model here, as you might have surmised, is going to be as follows. Is you're going to have, this is the strength of legislation and then this is going to affect the homicide rate. With homicide, with the understanding that, and the notion being that with more gun control legislation, you would potentially mitigate the flow of guns and also reduce the homicide rate. So what we're going to do here is the research question. I'm going to take this from the top, and this would apply to the hypothesis testing as well, because we're going to run a hypothesis test here, but here we're just going to say, is there a relationship or not? Our hypothesis is going to be the null, as always, that there is no relationship. But let's go for the research question. The research question is very straightforward. Will strengthened gun control legislation reduce firearm homicides? In the U.S. Okay, so our hypothesis, as I said before, is going to be there is no relationship. Okay, meaning you can weaken or you can strengthen firearm legislation all you want, but there's going to be no relationship between the strength, whether it's weak or strong, of the legislation to that of no relationship between the strength of legislation and the homicide rates in which we investigate, the independent variable being the homicide rate, or the outcome variable being the homicide rate and the input variable, or the independent variable being the strength of relationship, or actually the strength of firearm legislation. So first we're going to say no relationship, and then there is a relationship. That's going to be our alternate hypothesis. And the methodology we're going to use, we're going to do a linear regression. And we're going to do that. We're going to conduct the test at p.05, or the hypothesis test at p.05. And as always, if the p-value is less than 0.05, we would reject the null, and we would therefore go about accepting the alternate. The independent variable, as I discussed, and very consistent with the causal model, is you have the strength of legislation. And then the dependent variable, the outcome variable, the predicted variable, is going to be the homicide rate per capita. And we're going to run this at a significance level of 0.05 or 95% confidence level, as mentioned above. Now, the source of invalidity, we talked a little bit about that in class, and the invalidity, one that jumps out right away is that this is just 1 year. We also don't control for age. Some states might have a lower mean age or a lower average age in other states, and as the data would suggest, or as it's pretty obvious that a lot of gun homicides or firearm homicides are committed by people who are younger as opposed to older. So, but we're not controlling for that here. We're not considering that specific variable in the causal model. So let's see how it turns out just on a straight up confidence level, p.05, strength of legislation, homicide, and but recognizing that there are a couple of sources of invalidity that can come into play here, to be sure. We conduct this linear regression model, and as we've talked a number of times, is there are really only about 3 or 4 points of information here. One is the R value. This is the R squared. On a linear regression, we don't worry about adjusted R because there are no additional variables to adjust for. And then the other one here that you're going to come across is, obviously, we want to create the regression equation. And then the other thing, like I said, is we've got our old friend, the p-value. Okay, and you can see that the p-value is 0.36. So you may begin figuring out where exactly this is going. By the way, the p-value on a linear regression is the same as the p-value for when you're calculating the mean square error, and generally the f-value and the p-value move opposite of each other. So but really what you need to look at is just take a look at the p-values and say, okay, is that less than 0.05 or whatever your significant level is you're running the test, or is it greater than? Okay. So what are our findings? Okay. Our findings, the correlation is 0.13. So R equals 0.13. That would be considered a pretty weak relationship between gun control legislation, or strength of legislation, and the per capita homicides by firearms. Okay. So, and that kind of, and you would expect that. I don't know if you remember back here in the one graph. Let's see if I can find that real quick. And that's pretty much as you might expect, given the slope of that line that we saw back here. Right? If there were a really strong relationship, you would see a slope like this. Okay, that'd be strong and positive. And this is a positive relationship, but it's not very strong because there's not much slope here. Okay, and if the slope ended up, if there was no slope and it was just like this, that'd be perfect correlation, and this would be no relationship at all, which is pretty much where you're at, okay? And again, I'm not trying to overlead this, but let's keep pushing down the findings outline here. So the coefficient of determination is 0.016. That's the R squared. So let's call it 0.017. Now what that tells you is that, at least for this specific situation, the outcome variable, which is homicides, is 2% accounted for by the strength of legislation. That's not much, okay? So there's not much of a coefficient of determination to work with here. You've got a fairly weak correlation itself. You've got a coefficient of determination that's only about 2% explanatory value. But let's, again, we'll just keep putting the pieces together here, and you can begin drawing your own conclusions and recommendations. I'll do the conclusions, then you have to do your own recommendations, because I really don't want to get into, a lot of the politics and religiosity and everything else that is surrounding this issue. So the regression equation, this is your normal regression equation. Always remember you've got some error in there. And the way we create that regression equation, our model, is y is equal to b sub 0. B sub 0 is the intercept. So in this case, here is the intercept, right? So 2.42. Now let's just call it 2.4. Plus the slope, the only other value left here is the blended score. So that's the slope, 0.02 times x. And then you're always going to have a little error in there that's not accounted for, because there's, as we talked, there's probably many other variables that may come into play here as part of the causal model itself. So that's the value, or that is the actual regression equation. As far as the p-value goes, we talked about that very briefly. We know the p-value, okay? So p is equal to 0.36. And as you might begin surmising, this is not looking all that good as far as, if you are an advocate that more gun control legislation will reduce the number of homicides at a p.36, a weak R correlation, a coefficient of determination of about 2%, a very weak slope, or very, almost no slope at all, to the point where you could conclude there's almost no relationship. You would conclude very easily that there is no relationship between strength of gun control legislation, at least at the state level, as it relates to the homicide rate in the United States. So that's more or less how you would evaluate that. If you wanted to, oh, by the way, you could put a value in here. Let's say your strength of legislation was a 1. Okay, we've done this before in class. So y is equal to 2.4 plus 0.02 times 1 plus your error. So you would claim that y, and a lot of times you'll see this y hat, okay, is 2.42. And if that were a 2, if that was the value for your strength of legislation, then it would be 0.04, and then you'd be at a 2.44. As I said, you can draw your own recommendations on what you would recommend, but at least in this case, it would be fairly. You could be very confident that there is no relationship between additional gun control legislation and the firearm homicides here in the United States, with the understanding that there's error that's in there, the invalidity we talked about. So there's much more research that needs to be done, and this is just something that we talked about in class, and that is a data set that I developed for this example. Thank you.